Last time, 2 months ago when I updated you, we had 8 observers, 9 telescopes, we'd done 20 doubles and there were 97 observations. Now we're up to 11 observers, 13 scopes, we've had another month's worth of doubles, and that's about the number of observations we've got. We've actually got a few more than that, which I haven't put on the database yet. That's the database which I showed you last time. And this is just a graph, obviously in 2 dimensions of the numbers we've got. These blue points are the successful splits, the ones where we've been able to detect the 2 stars. The pink ones are ones where we haven't been able to detect them, which is in a sense the most interesting part. Last time I remember Tony suggested that we just sorted this out a little bit and coded it, which I've done in a different way. I won't go into a great deal of detail now, but the ones up there, this is the separation, so tough ones are down here, easy ones are up there. This is the aperture of the telescope. This is the Bradshaw beast. That's me with 1 failure, which I'm very depressed about. And then we go all the way down to the smallest scope we've got on this database is 125, but I've now got 2 lots of 80mm, so thank you very much for the John Cellini was one, and Max, no, not Max, who was the second 80?
I think it was me.
Might be Roy, yep. So, and they're not on here yet, so they're going to be very interesting to put on. So these are all ones that weren't split, and the seeing, I think it was Tony who suggested the seeing, is quite a strong influence. The ones up the top there, those squares, are ones that aren't seen at all by the telescope because it's beyond the limiting magnitude. Thinking about it, that's actually not very useful to us, so I'm not putting any more of those in the new stars that are coming along for targets. And you can draw a line between the big telescopes and the little telescopes, and you can draw a sort of funny line there between success and failure. But the really interesting thing is that I've gone on to try and model this data. I'm using, I think it's got a horrible name called the binary logistic regression analysis. Binary doesn't mean binary stars. It means the capacity to predict a yes or no situation. So heads or tails, yes or no. In this case, split, non-split. And it's reflected by this sort of graph. There's a probability. So 0 down here means that you haven't achieved it. 1 means you definitely achieved it. And somewhere in the middle, there's the possibility of achieving it. And along here is a combination of conditions. So basically, if you're down here, you're probably not going to split the star, and if you're up here, you probably are. And what the model does is to predict this as a function of the conditions. Don't worry about all that. This is the things that turn out to be important. The difference between the 2 magnitudes of the stars. All of this is intuitively sensible, by the way. A ratio of the magnitude of the second star, the dimmer one, divided by its separation, and that's a number that the bigger it is, basically the more difficult you are likely to be able to see it. The aperture of the telescope, which is driven by diffraction theory, so you expect that to be there, and the seeing, which is, I think, the first time anyone's actually quantified the impact of seeing. So that's the model, and I'll fiddle with this over the next few months. It'll change, I'm sure, but this is the one we've got going for us. Well, how good is it? At the moment, we're hitting 88% predictive accuracy. So of the observations we get, the model predicts 88% of them correctly and 12% of them wrong. These little graphs just show for the ones we failed to split, those are the ones we got right with the model, and that's the ones we got wrong, so there's a big majority. It's even better for the ones we can split. We can predict nearly all of those perfectly well. There's a few that are a problem. So in fact, it's the ones we can't split that I need more of, so I'm making them tougher and tougher. The next one that Graham talked about, the Scorpius, there's 5 in there that are quite hard, and 1 really hard one, which is for you. Hurrah! You get it, and I got it.
Okay.
Right? So this is private competition between the heavies and the Now, what does it tell us? Well, I've used the model now, which I think is quite good and will get better as the data goes, to draw these predictions. So up there is the critical separation, the separation that can be achieved by these telescopes, 6-inch, 8-inch and 12, as a function of the magnitude of the secondary. So as the secondary gets dimmer, the capacity to separate gets worse. They have to be wider for you to be able to split them. But down here you can see a 12-inch where both stars are of the same magnitude, 6, we can achieve definitely sub-arc second resolution. That's what the model says. And this is the AAQ model. So this is a bunch of amateurs with amateur telescopes. That's the key about this thing. It's not, the pros. And the effect of seeing is really interesting. This is really bad seeing. This is really good seeing. And again, that's the critical resolution. So at 8 magnitude secondary with 6 primary, the difference in seeing is somewhere between being able to get a 1.5 split and a 2 split, which is in this game quite large. So seeing turns out to be very important. And you can draw these sorts of nice graphs if you've got nothing better to do with your time. So which, as you know, is a problem that I do have. So it's three-dimensional graph. So that's the critical separation in arc seconds that you can see. This comes from the model. Here's the magnitude of the secondary. And here's the magnitude difference, and really what this says is that as the magnitude difference increases, it's much harder to split. You've got to have a very wide split, and the same for this. Now, compare this with the next one, this is bad seeing, and that's good seeing. I'll just toggle between those, and it makes a hell of a difference. So seeing is really important, and we've now got it quantified, now seeing obviously is the crudest measure that we have. Everyone probably has a slightly different way of interpreting it, but it's a lot better than nothing. I think if Tony said it was 2, and on a different observation I said it was 4, different night, they would definitely be different. There's no question. Whether you and I would agree on what was 3 is another matter. But we're getting there. How can we make it better? Well, I'm going to chuck out those ones that we can't see at all. I think that wasn't sensible. I'm also going to just have a look at if we remove the obstruction from the, well, not physically, but if we take it out, don't sue me, please. If we just take it out of the arithmetic, so I've asked everybody who's contributed, who's not got a refractor, to give me that information. That's starting to come in. This is a difficult one. I have some people have told me how old they are. The reason for this is not whether you're a doddering old fool who don't know what you're doing. It's all about your eyes, of course, and how good your eyes. And of course, more data. And what is the AAQ limit? The last time I reported it was 200 over D. This is a competition with the famous Eagle-Eye Doors limit, which I've talked to you about before. We're now down, the model says it's something like that for average conditions. There with Doors. Doors is very, very good. That's based on the theory of diffraction, and this is a guy who works at the Naval Observatory in the States, and we're kind of pulling it down, so we're getting a bit better, which is good. I just thought you'd be interested that this is the original paper from the Doors, the first ever announcement of the official Doors limit. Here it is. He says that I was thus determined, having looked at lots of stars and lots of telescopes, and he was a very good observer, if you remember, back in the 1867, as a constant that a 1-inch aperture would just separate a double star composed of 2 stars of the 6th magnitude, so equal magnitude, if their central distance was 4.56 seconds. That's the Doors limit. The atmospheric circumstance being moderately favourable. So he's not saying perfect seeing, but not bad. And therefore, there's the performance. Unfortunately, it's a long paper, but it doesn't say anything about the data or how you analyse it or anything else, but I'm going to go and track that down and see if I can find it. Just a reminder that thanks to Des's good offices, all this stuff's on the web. The latest stars from the latest newsletter are there, and the finder charts and so on. There's a couple of the IP finder charts, and Roy made a comment to make them better, which I've tried to do. Where to from here? Well, we want lots more observations. We're doing very well. I think 2 or 3 times what we've got, and we'll be in very, very strong shape. And as I said before, smaller scope, but we've now got a couple of those, so that's good. And don't have to be obsessed by this stuff as long as you do some every month. Tony's banned us from doing it tonight, but do it secretly when he's not looking. Okay.
Just look at the moon, planet's first, then do you?
No problem with that at all. And it's all on the website. So we're going well. In a couple of months' time, I'll give you another update. But thank you, all of those of you who contributed. It's really getting very interesting.